Hi, let's discuss about validating references with lifetimes. So, in chapter 4, we would have already taken a look at what lifetimes are, but let us go more in detail in this part. So, lifetimes are basically parameters that ensure that references are valid as long as we need them to be. And every reference in Rust language has a lifetime. Most of the time, lifetimes are implicit and they are inferred, just like most of the times types are inferred in Rust language. But we only annotate the types when multiple types are possible. In a very similar way, we must annotate all lifetimes when the lifetimes of references could be related in a few different ways. So the concept of lifetimes becomes very important when we talk about references. In Rust, it requires us to annotate the relationship using generic lifetime parameters to ensure the actual references used at runtime will definitely be valid. So annotating lifetimes is not even a concept most other programming languages have, but we have it here in Rust. So let us cover few points and concepts in lifetimes to have a better understanding on it. So the first section is how do we prevent dangling references with lifetimes? This is the part where we actually get to know what lifetimes is actually used for, since this is an unfamiliar concept because most of the programming languages don't have it. Let us just try to get an understanding on what lifetimes do exactly. Here is a simple piece of code snippet. I have a main function and I have a variable r and I have an inner scope. Here I'm saying that the value of x will be 5 and my value r is a reference to x. After the inner scope, I'm trying to print what the value of r is. So I get an error here saying that borrowed value does not live long enough. The point here is I have x which has the value 5 and the binding x is declared here. So in the scope, when I say that r will have the value that is the reference to the x, and after we close this bracket, the value of x is dropped here. And when I'm trying to print it, that is not possible. When I'm trying to print it, I'm trying to print in the outer scope. Here in the programming snippet, we can see that the r variable is valid from this point till this point when I close the bracket, close the function main parenthesis. But the value of x is valid from this point till only this point. It is valid only in the inner scope. It has, in other ways, we say that it has a lifetime from here till here. Its lifetime ends here. After this, I'm trying to take a borrow to the value x and then say that I'm trying to print the r, which Rust does not allow. So how do we visualize this part better? Here we can see that how would compiler see this particular piece of code. I say that the value r, the variable r, is valid from this point. Let us give it a lifetime called tick a. The way we represent lifetime is using a tick and a. This is the syntax to represent lifetime. So I say my variable r is going to live from this moment all up until this moment because it is declared in the outer scope. But my variable x is living only from this moment till this moment. Let us give this a lifetime of tick b. So by comparing these two boxes, we can see that the lifetime of a is this long, whereas the lifetime of b is only this much. This clearly shows the borrow checker that this particular variable, which is the x, won't live long enough for us to use it in the outer scope. So let us see in the next part how do we fix this. We have to make a minor modification to fix this piece of code. That is, we have to make sure that both the variables are living long enough so that we can print it here in the outer scope. So what we have done here is the x, which has the lifetime tick b, which in this case was larger than tick a. If we make this minor modification where the lifetime tick b lives longer than tick a, then we should be able to print here. That is because Rust knows that the reference in R will always be valid while X is valid. So let us try to run this code, and you can see that it compiles without any error. This is how the compiler checks for lifetimes of variables during runtime to make sure that everything is running smoothly. If we're trying to access or print a variable which does not live long enough, then it will give us an error. So the next part is how do we understand generic lifetimes in functions. So let us write a simple function that returns longer of the true two string slices. So this function will take two string slices and return a single string slice. And let's call this function as the longest. So I have a function here, it's called the longest. It takes two string slices, which is x and y, and returns whichever string slice is the longest. So one thing to note here is that we want to take string slices, not the strings itself. String slice is basically a reference to the string rather than taking the string itself, because we don't want the longest function to take ownership of its parameters. So we have string 1, which is ABCD, string 2, which is XYZ, and we're saying that the result will store after comparing string 1 and string 2, which is longest. The longest functionality is described here. It is going to compare the length of X string and Y string in an if and else block and return whichever is the longest. So what would happen if we try to run this? Would this work, or does this have something to do with lifetime as well? Let's find out. So here also we're getting an error. When we look at the error message, we see that it is expected named lifetime parameter. We see that it is expecting a named lifetime parameter where exactly this return value. So our Rust compiler is telling us that it does not know whether the return value will live long enough for us to be able to do this operation. So when we look at this help section that Rust compiler provides, this function's return type contains a borrowed value, but the signature does not say whether it is borrowed from X or Y. Consider introducing a named lifetime parameter. Here it is suggesting us to add a named lifetime parameter to try and fix this error. But what does it say exactly? It's saying that the return value could either be string X or Y, and it does not know how long each of them are living. Hence, it does not know how long will this return value live. But actually, even we don't know whether the if block will be executed and the X will be returned, or the else block will be executed and we will get a reference to Y, because it depends on the size of each of these strings. So when we're defining this function, we don't know the concrete values that will be passed into the function. Hence, we don't know whether the if case will be executed or the else case. So how do we do this? The borrow checker cannot determine this either, because it doesn't know how the lifetimes of X and Y relate to the lifetime of the return value. So to fix this error, we have to add a generic lifetime parameter like it has suggested here as, so that we can properly define the relationship between references so that the borrow checker can perform its analysis. So basically, we understand that by adding this tick A here, we are defining what is the relationship between the references. This is called as lifetime annotation syntax. This does not change how long any of the references will live. When I add tick A here to the longest function and say that X will also have the lifetime of tick A, so will the Y and the return value. I'm not saying how exactly each of these parameters living, but rather I am just saying are what is the relationship between all these parameters. So let us first take a look at lifetime annotation syntax since we're already here. And then let us fix the function that is not working and that is giving an error here with the help of this help section that the compiler has provided us. So by now, by looking at the help section from the compiler, we should be familiar how do we showcase the lifetime, that is using a tick and a variable. Here we can see that this is a simple reference. It says it is a reference to an I32 value. But when I have to say that this reference will have an explicit lifetime, when I want to denote the lifetime of this I32, I say tick A. Similarly, when I want to say that the I32 value is mutable, I say ampersand, which means that it's a reference, tick A, which is denoting the lifetime, mut says that it is mutable, and the variable will be of type I32. This is the syntax that we use. And these are few of the examples that says how without a lifetime parameter a variable would be, or how am I defining the type without a parameter, without a lifetime parameter, and how with a lifetime parameter I'm able to define the variable. So one lifetime annotation by itself doesn't have much meaning because the annotations are meant to tell Rust how generic lifetime parameters of multiple references relate to each other. So with this knowledge that we have, let us try to fix the previous function. So the compiler has already given us a clue saying that we need to add lifetime parameters to be able to fix this function. So now I still have my main function, which has two strings a, b, c, d, and x, y, z. After fixing the longest function, saying that all of this will have a lifetime of tick a, my longest function should return a, b, c, d, which is longer than x, y, z. So let us try and compile. So now we can see that it is building without giving us an error. Cargo run gives me my result saying that the longest string is ABCD as it has 4 values, whereas XYZ has only 3 values. So let us see another function to understand lifetime annotations in function signature. So in the previous case, for the longest function, we saw that the function signature basically tells Rust that for some lifetime, that is tick A, that function takes 2 parameters, both of which are string slices, and they live at least as long as the lifetime tick A, and this is the case for the return variable as well. So in practice, it just means that the lifetime of the reference returned by the longest function, that will be same as the smaller of the two lifetimes of the values to referred by the function arguments. Basically, we want to specifically mention what is the lifetime relationship between the parameters that the Rust code is analyzing. So now basically with this piece of function, let us try to look at how lifetime annotations also restrict the longest function by passing in references that have different concrete lifetimes. So in this example that we have taken, string 1, it is valid until the end of this outer scope, whereas string 2 is valid only in the inner scope. And the result that we're trying to print, that references something that is valid until the end of the inner scope. So when we run this code, we will see that the borrow checker approves it and it should compile. I need my longest function, but the function main changes. So now I have my longest function and my function main has changed. Right now what I have one string that is valid till the end of the outer scope, and I have second string that is valid till the end of the inner scope. But my result, unlike the previous time, is trying to see. Let us just compile and see. So my output from the result value is that the longest string is long. What is basically happening is my string 1 is living from this point till the end of the outer scope. My string 2 is living till the end of the inner scope. And my result, when we ask the longest function to return us, whichever is longer, that is whether the string 1 or the string 2. And we see here that the string 1 has long string is long. So it is obviously returning a string 1, which lives until the end of the outer scope. Hence, my result is able to compile without any problem, because the lifetime of string 1 is till the end of the outer scope. So it's printing the longest string is long string is long. But if I change this to the string 2 and make string 1 as XYZ and now try to compile, my function should not work. Well, sorry, my function should work because string 2 is valid in the inner scope and I am trying to print the result in the inner scope only. So technically it would not work if I was trying to print string 2 in the outer scope. We could try doing that. Now I can already see that there is going to be an error. Now the error says that the string 2 is available in a different scope in the same function. So my string 2 does not live long enough for when that I'm trying to print in the outer scope. Let us continue discussing more about this in the next video. Thank you.